Welcome to section 3.3, where we're going to discuss three different forms of the equation of a line. All right, our first form of the line is slope-intercept form. Slope-intercept form gives you a starting point on the y-axis. We call that the y-intercept. It is the point 0, comma b. So whenever you have the y-intercept, the x-coordinate is 0. Our slope is m, that's going to be the value multiplied by x. So to write this equation, you identify or find your slope, you find your point, your y-intercept, and then you substitute the values into our equation. So again, this equation of a line has to go through the y-axis at 0, comma b. So it's very restrictive. It has to start on the y-axis. The second equation of a line is called point-slope form. This again has slope m, but now this contains the point x sub 1, y sub 1. The sub 1s just means that's some point, the first point that you look at. Now this point can be anywhere on your graph. It does not have to be on the y-axis. This equation is very helpful when you have an equation of a line that doesn't pass through the tick marks on the y-axis to give you, say, a y-intercept of 4 or a negative 3. It's somewhere between the tick marks. It's a fractional value and you don't know what it is. This form of the equation is better to use because we just look for a point that hits the grids on the corner and we have an exact point. So to find this equation again, you'll find your slope, you identify your point, you substitute it in. Again, it's really important to understand that x sub 1, it's going to be x minus x sub 1. There's a sign change on your x coordinate. There's a sign change on your y coordinate. So if I had a negative x coordinate, say negative 2, this would go in as minus a negative, which turns into a plus 2. If this was a 3, then it's just y minus 3. All right, moving on. Now, how do we find the slope? Well, if you're given 2 points, x sub 1, y sub 1, x sub 2, y sub 2, we're going to use this formula here to find our slope. You subtract second y coordinate minus the first y coordinate. Subtract the second x coordinate minus the first x coordinate. Change in y over the change in x. Once you find your slope, then we can go back and you can use your point slope form or your y equals mx plus b slope intercept form if one of your points happen to be your y-intercept. If you're given equation of a line parallel to a given line. Now, sometimes here, when you are talking about parallel to a given line and also perpendicular to a given line, you're going to have to find the slope from those given lines. Now, when we talk about parallel, slopes are the same on parallel lines because they're never going to intersect. So the slope is easy to find from a given line. If you're given a line that's in y equals mx plus b, slope intercept or point slope, the slope is right there. However, most of the time, the given line is what we call in standard form. Standard form has no fractions in it, whereas slope intercept and point slope will have fractions because of your slope. Could be a fraction. So old school technique for writing an equation of a line is standard form where a, the coefficient in front of x, plus b, the coefficient in front of the y, is equal to c. All these capital letters are integers. They're very rarely a fraction. It's common practice to keep those integers. So if you have the x term and the y term on the same side equal to a constant, then you take the opposite of the coefficient on the x, negative a, over b. In essence, what we're doing is you're solving this equation for y. I would subtract over the ax and divide over the b, and that creates your slope. So this is a fast way to find the slope of the given line, so you can use it in the equation of your new line because the slopes are going to be the same. Then you identify the point on the line that you're trying to find, substitute it into either point slope or slope intercept form. You may have to convert point slope into slope intercept form, which we'll show you how to do. If it's perpendicular, your given line, now taking the same information that we used up here, but because it's perpendicular, the slopes aren't the same. What happens here is now you want a perpendicular slope, which is its opposite reciprocal, which means you're going to change the sign of this slope and flip the fraction. So if I had a line, given line, here's my slope, negative a over b, or maybe say negative 2 over 3, you would flip the fraction to 3 over 2 and change the negative to a positive. That would be the perpendicular slope. Then identify a point that you would have on the line that you're trying to create and substitute it again into point slope or slope intercept form. All right, so let's go ahead and practice some of these. Here we have 2 points, 3, 7, and 0, 3. On a line, find its equation y equals mx plus b form. Okay, we have a special point here. 0, 3. Anytime your x-coordinate 0, that's your y-intercept, so that's your b. So this 3 right here can go into your equation right there. That's going to be a plus 3. So we need the slope. So we go to the slope formula. 3 minus 7, second y minus first y over first x minus second x. 3 minus 7, that's going to give us a negative 4 over negative 3. Okay, well, you're working with negatives. It is also allowed that you can also go first y minus second y, as long as you go first x minus second x. So the order in which you do subtract your y coordinates and x coordinates, it doesn't matter as long as you stay consistent. Second y minus first y over second x minus first x, or vice versa. First y minus second y over first x minus second x. Either case, we subtract, you're going to get a slope of 4/3, which we can substitute in for m, and there's the equation of my line. Okay, number 2, the equation of a line with an x-intercept of 1 and a y-intercept of 0.6 can be written in the form of y equals mx plus b, where we got to find the slope and we got to find the b. Well, since the y-intercept was already given to us, that's your b, so b equals 6. To find my slope, we got to take your x-intercept, that's 1 comma 0 for a point. Your y-intercept is 0 comma 6, and then we have to apply the slope formula like we did up in number 1. 6 minus 0 over 0 minus 1, or 0 minus 6 over 1 minus 0. Either one is fine. Whatever you do, you're going to get negative 6 for the slope. So I have my slope, I have my y-intercept, I can write my equation y equals negative 6, that's my slope, m, times x plus my y-intercept of 6. All right, number 3. If a line has an x-intercept of 3 and a y-intercept of negative 8, find the equation in the form of y equals mx plus b. Very similar to number 2, so pause the video and try it yourself. All right, welcome back. Here we are. There's my y-intercept. X-intercept 3, 0. I need to convert that into a point like we did before. We needed to subtract. Hopefully we went 0 minus negative 8, which changes that to a positive. 3 minus 0 gives me 8/3. So y equals 8/3 x minus 8. All right, number 4, find the equation of a line with slope of 3/2 and passing through the point 4, 9. Okay, so there's no 0 here, so this is not a y-intercept. So this is going to need our point slope form of the equation, this equation right here. All right, so what we're going to do is we're going to substitute this into our equation right here. So our slope is 3/2, that's the m, so it's going to be y minus 9 and x minus 4 on the inside. Then we want to convert this into y equals mx plus b. You have to distribute the 3 halves. So 3 halves times x is 3 halves x. 3 halves times the minus 4, well, 2 goes into 4 twice. So 3 times 2 is 6, so minus 6. Add over the 9, and we get y equals 3 halves x plus 3. Number 5, find the equation of the slope 6 and passes through 750. Again, same situation up here. Using point slope form, we're going to have y minus 50 equals 6 times x minus 7. Solve this for y. We'll distribute the 6. To get 6x minus 42, we'll add over the 50. To get 6x plus 8 is equal to our y. There's my equation, y equals mx plus b form. All right, writing the equation given a graph. In this case, always check your y-axis first. If you hit a tick mark perfectly, there's my y-intercept, 0, 2. Then the next thing I would do is scan your line, looking for places that it crosses the grid lines right on the corner. There's one here, there's another one here. And then compare it. Down 3 to the right 2. Down 3, right 2. That stays consistent, so there's your change in y. That's your negative 3 is your change in y. To the right 2 is your change in x. That would be your slope. So now that I have my y-intercept, b2, and I have my slope, I have the equation of my line. All right, so number 7, same situation. Go ahead and pause the video, write your equation. When you're done, come back, we'll check it. All right, welcome back. Here you have a y-intercept at 1. I have a point here, I have a point up here, I have lots of points. They all appear to be up 2, right 1. So that's a slope of 2 over 1, or just 2. So my equation is y equals 2x plus my y-intercept of 1. 8, find the equation in the terms of x of the line through the points negative 3, 4, and 2, negative 2. This statement here means you just have to get the y by itself, and everything on the other side can be constant numbers, but it has to have the variable x. So the first thing we're going to have to do is, given that we have 2 points, is we're going to have to find the slope first. So we're going to go second y, negative 2, minus the 4, second x2 minus the negative 3. That's going to turn that into a plus. So we're going to get negative 6 over 2 plus 3 is 5. There's my slope. And since neither one of these points have a 0 for an x, I'm going to use my point slope because I don't have my y-intercept, and I'm going to substitute in some points. All right, so my slope goes in for m. You can pick either point you want. I'm going to choose negative 3, 4 because these two numbers are closely related, but the signs, I want to make sure you see where these go. So this is going to be x minus a negative 3, so that will change this to x plus 3. And over here, the y-coordinate of 4, y minus 4. And of course, there's my slope in front of the parentheses. Now, they said, find the equation in terms of x. All you have to do is add over the 4. Y is by itself, and everything else over here is written in terms of x. You do not have to distribute this. They did not say write it in y equals mx plus b or slope-intercept form. Whereas in number 9, notice it said write your answer now in y equals mx plus b. Now you would have to distribute that slope into the parentheses. So again, here let's find the slope. Second y minus first y minus a negative 24. 16 minus another negative 24 plus 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 gives me 55 over 40. These are divisible by 5. Looks like we're going to get 11 over 8. There's my slope. I'm going to opt to use 16 and 31 again because these two are the same. So it's going to be y minus the 31 on the left, 11 over 8 times x minus 16. Now again, because they want y equals mx plus b, we'll distribute the 11 over 8, which is good because 8 does go into 16 twice. So we can cancel that and get a negative 22 when we multiply those together. Then we just have to add over the 31. 31 added to a negative 22 is a plus 9, and there's my equation. Okay, number 10 is very similar to number 8, so let's try this on your own. Just like number 8, have it as y equals, just add over this or subtract over whatever we have over to the right. So go ahead and pause the video and try it on your own. All right, welcome back. So first you should have the slope, negative 3 minus 3. Second x2 minus first x, negative 4. We're going to get negative 6 over positive 6. We have a slope of negative 1. Pick either point you want. So y minus 3 equals negative 1 times x plus 4. All right. Here we could take it a step further to write in terms of x because you have a negative 1. Where here, negative 6 over 5 was difficult to multiply to this 3 because 5 doesn't go into 3 evenly. We can distribute the negative 1, which makes it negative x minus 4, and then just add over the 3 to negative 4 to get y equals negative x minus 1. So this one we could take a step further because it was easier to multiply in the slope because it was an integer as opposed to a fraction.